Okay, so this is part 284C3M1B7C8E13C9C6D3A. This is line 22f1fa19c3m1b7c8E13c9c6d3a. Hemocyanin or hemocyanin ions, binuclear copper formula 5G Wow Seti. Here's our alien radio signal, and this video is going to do keyword research for metals, ions, copper, electron transfer, transport, and alien technology from the well data. Keywords from the data continues in the next video is going to be divalent plus efficient electron transfer path for reduction of the bound N20. N2, I don't know if it's a 0 or N20. Okay. January 12th, the keyword hemocyanin, metals from the previous video. Today is the 14th. Line 22f1fa19c3m1b7c8e13c9c6d2 is blue oxygen plasma photons formulas UFO 5G Wow Seti that has some really unique formula ideas in it. So take a look at it. Quote PDF from the blog. The metal ion interaction. Actually, it's got about 6 or 7 formulas if you want to know the truth. Quote PDF from the blog. This is a metal ion interactions with Limulus. There's our L word. We found it. Limulus. I'm going to add that to my other formula. Okay, Limulus, polyphemus, and Callinectes, sapidus, hemocyanins, stoichiometry, and structural and functional consequences of calcium, cadmium, zinc, and mercury binding. Where do you guys come up with these words? Oh boy. Hemocyanins are all. I did not look up all these words. I didn't think it was necessary yet. Okay, so hemocyanins are oligomeric metalloproteins containing binuclear copper centers that reversibly combine with oxygen molecules. The structural stability and functional properties of these proteins are modified by divalent cations. Equilibrium dialysis was used to study the reversible interaction of Callinectes, sapidus, and Limulus polyphemus hemocyanins with the divalent cations calcium, cadmium, zinc, copper, and mercury. My tongue's getting a workout here, right? The number of binding states and association constants for each cation were obtained from an analysis of the binding data by a non-linear least squares minimization procedure. Spectral analysis showed Limulus hemocyanin to possess 2 mercury reactive sulfhydryl groups per subunit. And there's your equations there. Callinectes hemocyanin contains only 1 such group. Okay, so cadmium and zinc are shown to substitute for calcium ions. Oxygen binding studies with Limulus hemocyanin showed that all 5 divalent metal ions increase its oxygen affinity. Calcium ions increase cooperativity of oxygen binding, while heavy metal ions have an opposite effect. The binding of 2 mercuric ions per Limulus hemocyanin subunit irreversibly fixes the 48 subunit aggregate in a high affinity non-cooperative conformational state. These results offer a striking contrast to the functional consequences of heavy metal ion interactions with Callinectes hemocyanin. Okay, so that's from the scientists that are working on it from 1982. Oh, great! Look at this. See what I did over here? I made my formula and forgot to stick it in where it's supposed to go. Just put it here. You tell I did this at 3 o'clock in the morning last night, so I apologize that I'm kind of like out of it right now. Tired. So I only had about 3 or 4 hours sleep. So the functional alterations associated with metal ion interactions are discussed within the context of an extension of the 2-state model for allosteric transitions of Monod AL. And that's all the people involved in that one from 1965. Cool. Incubation of Limulus oxy or deoxyhemocyanin with mercuric chloride results in the conversion of 60% of the binuclear copper sites to stable half-apo sites. The remaining active sites are stable with respect to mercury-induced copper displacement when oxygen is bridging both coppers. In the absence of oxygen, these sites will eventually lose both copper atoms. And we have copper atoms in our formulas, right? Under the same conditions, 50% of the binuclear copper sites of Callinectes deoxyhemocyanin are converted to half-apo sites. In this case, oxygen completely protects against copper displacement. Again, there's the scientists that worked on that. 1982. The binuclear copper center of Boson Carica is not affected at all, demonstrating profound differences between the active sites of hemocyanins or of a chelocerate arthropod, Limulus, crustacean arthropod, Callinectes, and gastropod mollusk Buzicon. I'll write down Buzicon as another keyword. So I'm actually going to throw that in. It's not going to be in the next video, but I'm going to add it because it's sticking out there for me. So this keyword, Buzicon, to be Googled. Okay, and I'm making a note on my notebook to add it to somewhere else. Actually, I got a research data there. Hold on. What I do is I just stick it together like that and add it over here. So you just add a new subpage. So I'm going to do a keyword there. And then what I'm going to do is go back to this one where I found it from. And I'm going to copy and paste the title of that video so we know where it came from, because we got lost last time when I stuck a keyword there and couldn't find out where on earth I got it from. Not another one. Okay, so let's go back to this one, and I'm sorry again for being so disorganized. Okay, so that's where it was published on www.ncbi.nlm.nih.gov. And there's a link there. And this is a formula from the data. So you have a metal ion interactions, binuclear copper centers, atoms, alloys, reverse combine oxygen molecules. Structural stability, proteins modified, divalent, cations, equilibriums, zinc, copper binding states, nonlinear, repeat keywords in line 22's WOW data, square, spectral analysis, groups, metal ions, oxygen binding, heavy metal ions, superalloys in the WOW data, see cross-reference video, and copper displacement. There is a cross-reference video coming up, just so you know. In the next 5 or 6 videos, okay? Might actually be in the next one, you never know. There was like 35 videos that came up for it. It's crazy. Actually, sorry, I didn't do the superalloys. I did something else. Never mind what I just said. Copper displacement, copper atoms, binuclear copper and oxygen, and add protect, copper displacement, and then the keyword divalent is going to be in the next video, and keyword Buzicon is going to be Googled in another video as well. Okay, thanks for watching.